make alcohol. Then there's a boiler in the next room there, or maybe we should move to that, to the boiler. 5 horsepower boilers that is used to cook the mash and also operate our still. It's a low pressure boiler operating between 0 and 15 pounds. This here is a pump that is used to pump the mash through the cooker and into the fermenting tanks. This is our cooker. The equipment we have here handles 70 bushels per batch. So this is our cooker. It holds 2,300 imperial gallons. So what is needed for a proper mash is 25 gallons of water per bushel of corn. And the reason for cooking a mash is to kill the bacteria, the microorganisms that compete against your enzymes and your yeast. Enzymes are used to convert the starch to sugar. The yeast converts the sugar to ethanol. After the cooking process, we pump the mash into the fermenting tanks. These are fermenting tanks. It takes 70 hours fermenting time, and then we start the pumps up again and we run it through this separator over here. We separate the residue. The residue is what's left after the starch has been used up in the production of ethanol, and the residue is a very high protein food that can be used as a concentrate for livestock production. It's about 28–30% protein, and because of the cooking and fermenting, the nutrients are almost totally digestible. Where the distillation occurs, we have a number of heat exchangers in here that saves a lot of energy. We use the hot water coming from the still to heat the liquids that going into the still. These are the distillation columns, and we find that after we've installed a number of heat exchangers that we were able to save between 1/3 and 50% of the energy that we were using before. This is the distillation columns, and to regulate the purity of the alcohol, you must control the temperature, because if you get the temperature too high, you boil out too much water with the ethanol. Ethanol vaporizes or boils at 173 Fahrenheit, and of course you know that water is 212, and that's how the separation takes place. This here is the finished product. It's very clear, just as clear as water, although this has been denatured with 1% gasoline, according to regulations set by government. This automobile has been using 1/3 ethanol for the last 7 years without one moment's problem. It's a dual fuel system. We have another tank in the trunk, and it's a little needle valve. It's very easily converted. There's a little needle valve that hooks on the side of the carburetor, works off the back end of your motor. So it's very simple to operate. The automobile, the motor starts on straight gasoline. As soon as there's a vacuum buildup and you touch your accelerator, there's small cables that hook from the needle valve to your accelerator. It opens up the valve, gives you a dual fuel system operated motor. Here is a diesel tractor, a massive Ferguson, 105 horse, that is really a government research project. We've been testing this tractor for 3 years now. This tractor uses 50% diesel oil, 50% ethanol. After 2 years' work, the tractor motor was taken apart and tested for any wear and tear, and there was no excessive wear in the between the injectors, so we were quite pleased. You see, that's the other tank here.
Yeah.